My name's Simon Luff. I work for a company called FB Hurley. I've been using 3D software now for 3 years, and we've completed 10 projects. My talk is based around Revit, which is one of the choices you can make in terms of using 3D packages. I've based it around that because that's the software that we use, but there are, as Keith has mentioned, other products available. So with Revit, there are actually two types of Revit you can have. You can have the LT version or the full version. The full version would allow many users to work within the model at the same time. The LT version just allows a single person. So what that basically means is in the full version you could have one person putting pipes in and another person putting ducts in, and that is actually within the same file. So the LT version is more akin to a smaller business using on smaller projects where you don't need the speed of having a number of people working in the same file. One thing to add on to that is anybody involved in the project has to have the same version of Revit. So if they're using 2013, everybody needs to be in 2013. And the reason for that is it's not backwardly compatible. Autodesk have been a bit naughty really in the fact that they don't allow you to do that, so you have to keep upgrading all the time. But provided everybody's in the same version, it works fine. And every time they bring out a new version, it gets a bit better. So we started off in 2012, and it was a bit buggy at times, a bit slow at times. We're now using 2014, and the constant development means that they're adding stuff to it. It's getting better and better. Keith has already touched on the project setup. Each person involved will have their own separate model. So the structural guy will have his model, the architectural guy will have his model, the M&E his model, and you basically take the models from other people and link them into your model. You can see their models, you can't alter their models, not that you would really want to. So just a little example, you've got the steelwork on the one side there, the architectural and the M&E models. They're all combined together, and the M&E model, which is what I would be interested in, is the bit I can see and the bit I can alter. Keith mentioned families earlier on. Basically, anything you're actually putting into the model is a family. I've given a lovely example there of a wash hand basin, but it could be anything. It could be a valve, it could be a boiler, and that family has all the information associated with it. So it'll have the exact dimensions, the colour, the height that it would normally be put in, and you load that into your model, and then you position it as you like. Some of them have connections on if they're 3D models with M&E bits and pieces in, so they'll have pipework connections, electrical connections, and those may have flow rates associated with them as well. When you purchase the software, you get some families. You don't get a lot, and they're a bit basic. So what you need to do is develop your library. So you'd go to a manufacturer and say, can we have your models, please? 3 years ago, when I went to a number of manufacturers and said, can we have your families, they were saying, what's BIM? It has got a lot better, even though I spoke to a boiler manufacturer this week, and he said to me, oh, you asked me about BIM 6 months ago, and now we're bringing out our families, but you're the only guy that's asked me. And so there's still a lot of people out there that aren't using it. The National BIM Library, from an M&E perspective, is not very good. It's basically architectural items, but manufacturers are getting better now. You can actually go out there and get what you need from most of them. We circumvented that situation by purchasing a bolt-on called MagiCAD, and MagiCAD has over 100,000 families already pre-built. It's pretty good business software. It bolts in, and you basically download from that software what you want. So I thought I'd run through what we found to be really good about BIM. I think understanding the building is a really useful thing about being in 3D. No longer do you get your 2D drawings and you're wondering exactly where all the ceilings are. Is this an atrium? You can see it. You can do views. That's actually a view from inside that building, drawn with a camera. The architect has already put colours on the walls. So very quickly you can understand how the building goes together. From a coordination point of view, that is a model which has just I think it's just the ventilation in, and there's a bit of tray work in there. It's a job that we were in Revit and everybody else was in AutoCAD. We've kind of made the decision that we wanted to do everything in 3D. Just purely from a coordination point of view, you can do a clash detection, you can see what's clashing, move the bits and pieces around. It's obviously not perfect if you're the only one in Revit, but it's good to make sure that your bits fit. You get 3D visuals of what you're drawing. So if you're putting ductwork in, you can make sure that it all looks right, it's all going to the right place. And this particular plant room was a very complicated one, and I don't know how we would have done it in 2D. We couldn't have got that message over to sites just by putting a 2D drawing out. Drawing a section, you basically draw a line. Where you draw that line, you click on it, and it draws the section for you. You can move that line, and you'll get another section at a later time. That particular section shows a ceiling and some lights floating in mid-air. Once we'd drawn that out, we went to the architect and said, "Can you please move the ceiling down?" That's what happened. And working together with the architect is a lot more. There's a lot more correspondence going backwards and forwards. We're doing it on a daily basis. Keith's already mentioned about material takeoffs. You can schedule whatever you like, whether it's pipework, ductwork. From our perspective, might be window frames if you're into windows. And then you could actually put prices in. I know that one of the fan companies, Newair, actually they do a design and then they price the design using Revit. You could do walkthroughs. I haven't done a walkthrough for you. It would take too long, but you can do a walkthrough and have a look at all the bits and pieces within your model. But you can also see, as I've shown with the other 3D image, that's a plant room, and you can see that it all fits in, the space for maintenance, and you can get the message across the site a lot better than you can with a 2D drawing. If you're into doing design, this is an analysis section. So the colours actually mean velocities. So from a ductwork point of view, you don't want too much velocity. We can see straight away whether there's a problem, and the part on the side there where you've got the details, that actually tells you what resistance is through that particular part of the duct, so you can quickly check within the model what's going on. You colour things as you're going along. You can issue stuff to site which is all nicely coloured in. That's quite a useful part of it. The MagicAD add-on allows us to actually use it for design capabilities. So very clever. We give a radiator a kilowatt loading, connect all the pipework up, click at the end of the line and say we want all this pipework sized to a certain resistance. It gives us a list. We say that's okay, that's fine. And when you say go, it will then redraw the pipework to the right size for that particular resistance. So if you issue something out and someone says you've done it on 300 pascals per metre, but that's wrong, you should have done it at 250, we can redo the sizing in it takes about 10 minutes. It would redraw all that, and all the associated tag notes would all change at the same time. So it's a very clever bit of software, and it does ductwork, and it also does noise calculations. The learning curve. Having used it for 3 years, 3 years ago was to get to grips with it was difficult in some ways. We've learned a lot of lessons, so I thought I'd just pass on the things that we've learned. Our guys on site, because we're installers, they don't really understand some of the detailed drawings. They're used to seeing a 2D single line pipework drawing. If you give them a double line drawing of pipework, they're not used to dealing with that. Not with buildings, maybe with ships or something like that they would be. So you need to learn how to manipulate the software to get something to site that people understand. Down at the bottom of that chair shows the levels of detail that are available in each family. The other thing we found is that actually getting the message out to the guys on site is all very well drawing it all in 3D, but the guy on site that's installing that pipe down a corridor how does he know what height that pipe will be installed at? So you end up issuing more information, doing more detailed sections. Now, that might be more work in terms of what you're issuing, but it's not actually more drawing work because it's already within the model. You can produce room elevations, it's already within the model. 3D information, and you can see the two samples there that one has a whole pile of stuff on it, and how could you possibly read that? And the other one's slightly better, but you can turn off and on, say the pipe work, you can turn all that off and just see the ductwork to get your message across to site. What all this means is that you end up issuing, or we as a company have ended up issuing a lot more drawings for each project to get the message across. So otherwise it's pointless doing it in a 3D unless you can actually get the guys to install those pipes where you want them to be on site. Another thing we found, whoever's actually working within Revit and putting your design together, they need to be, no disrespect to technicians, but whoever's putting in there needs to understand how those pipes physically need to be installed, or ducts, or tray work, so that what you're drawing is meaningful and it would actually go in on site as per your drawing. So what I would say is that if you're thinking of investing in 3D software and you're overseeing a number of engineers, don't just rely on the 2D information that pops out. You need to actually look at the model and see what's happening in the model to understand, to make sure that you haven't got a pipe that's going up, down, up, down, up, down, which on site would just airlock. Couple of things about how we went about learning Revit. Went through a few lessons. You can use video software to. It's not that expensive compared to a day's training. You can get a video for just over £100, and YouTube is free. There's a massive amount of clips on YouTube of how to do various things. One really important thing is you need to agree with the people you're working with who does what. Who does the taps, from our point of view? Who puts the toilets in? Is it in the architectural model or is it in our model? You need to agree what level of BIM you're doing at an early stage, as Keith mentioned. We're somewhere, well, we're doing some of 7D, we're doing some of 4D, and all of 3D. We don't use it for estimating as yet, but as time goes on, I think we'll be developing our use of Revit and hopefully move on to that. Like all software, occasionally you have some problems with it. Those two error messages, the bottom one is the worst one you can get. It doesn't give you the chance to save your work, which is kind of annoying if you haven't saved it for a couple of hours. And the one above gives you the opportunity to save, so it's quite pleasing if you see that. So what I would recommend is, if you are investing, to stop those crashes. We found, because we were using basically a normal computer box, for want of a better word, with an upgraded graphics card, I would suggest as a minimum you go for 16 gigabytes of RAM, a really good NVIDIA or whatever the other company is, I can't think of what it is now, graphics card company, and a large monitor, and that will stop most of the crashes, because we did experience a lot of crashes by using hardware which probably wasn't up to the size of the models we ended up working with. I've whizzed through that pretty quickly because I think we were a bit longer than expected on the first bit. I'm not sure. Anybody got any questions?
Hi, I'm Patrick.
Hi.
I'm a member of staff here, and I'm a fan of safety, and I want to ask you something about it. And so, from your own personal experience, to what extent do you feel, to what extent does this help you in terms of designing for safety?
I think it gives you an overall better understanding of where plant is going to go. in terms of, as the 3D images, you can understand how it's going to be maintained better, so you've got space to put things in better. I think making sure you've got space to install things more than anything else. And I can't say I've really given the benefit of it from that aspect a massive amount of thought. But yeah, I would say that in terms of just making sure you've got maintenance space is probably one of the main aspects. I would say that you definitely benefited from that because you can see how to get at things. Rather than having a massive pipework in the ceiling you just can't get to, and you've got to climb on top of it, which you wouldn't want to do, you can leave space to actually get up there and sort it out.
Simon, just on that, is that something that you mentioned about experienced engineers needing to design, how things are put together?
Yeah.
Or do you actually sit your maintenance people in front of the model and say, do you think you can do that?
Well, we don't have per se a maintenance arm in our particular company. We have installers, so if they can install it properly, we'd be sure that they'd be able to maintain it properly. I'm using my experience and also our other engineers' experience to make sure that we're leaving suitable space as we're putting the model together. I mean, if you're putting together a 3D arrangement in a plant room, and you just physically haven't got enough space, and you can see and prove you haven't got enough space by using BIM, and then you go to your friendly architect and say, look, it's too small, you're going to have to increase it. So it does give you some ammunition, if you like, to prove your case. Although you don't have to prove your case these days. I think most people we work with are very cooperative, and you don't have to go saying, oh, well, look, there's something that we can't work with.
I'm an architect, and I'm quite curious as to how early in the process do you get involved or collaborate with the rest of the team?
Well, it really depends on the company that we're working with in terms of main contractor. We're working with, should I mention names? We're working with ISG at the moment, and we've got that school I put up there on the screen. They've actually started on site, and we've got an architecture and a structural Revit model, and they're saying, well, we need everything straight away. With BAM, we're on another job. We're actually on Students' Union here in UE, and we're putting pipes in the model, and the model's only been out a week. So it really varies from case to case. Obviously, we're stuck with certain aspects of the other project because we've been brought on at such a late date. The majority, I would say, it's been early.
So would you, I'm just thinking in terms of, say, the type of information that you're going to provide, how early in the process do you agree with the other consultants?
Literally straight away. On the UE job, I'll take that as an example. We had the layout plan that had been agreed spatially with the client. No plant space, no riser space, as would normally happen. We then said, right, okay, we want this plant space, this riser space. It's then added to the drawings. We're now populating those particular spaces with air handling units and boilers to make sure that that's all okay. If we encountered a difficulty at that point, we'd then be going back and saying we wouldn't say it's too big, well, not normally anyway. But if it's too small, we would then obviously highlight that and get the plant room or riser space enlarged as necessary. But it literally is. I'm badgering the architect for the elevations at the moment, saying I want your elevations because, and he's still working them up. So it is. We are literally a week behind the architect on that particular job. Just depends really.
I'm just interested in the process really. How does it start off? Is it the architect that creates the shell originally and then?
Yeah, the architect would build the building essentially, his model. So he would put the floors in, the roof, the walls, all the architectural bits. I would then ring him up and say, right, okay, we want to get started on it now. Can you give me your model? He gives me the model. I create my own file, and we link the architectural model into it. So it's a bit like an XREF in AutoCAD, well, exactly the same really. And then we would start then to put our pipes. So I can see his architectural background, and then add my pipes into it. One of the examples I showed, I said that no one else was in Revit. In that particular case, we get the architect's AutoCAD drawings and put those in each level. We put the architect's drawings in, and then we draw on top. So when you look at it in elevation, you see a line. You can't see any building, and then you see all our bits and pieces. And what you can do is you can take a section through the building, and where that's actually cut, you can put the drawing in, turn it on its side, and then you can see when you do an elevation, you can see your bits and pieces on top of the. So that's actually a bit of a cheats way of doing it, really, but it does work quite well.
And what happens if two trades, for example, are working at the same time on different things, and as those two packages go back into the main build, there's a conflict? Does that flag up? I mean, who's wrong?
Well, yeah, that's a good question. Well, obviously the structural and the architecture, you're not really going to move that, so it comes down to the M&E bits really. A lot of the jobs we've done the M&E. We've done both, so we've avoided that problem. With other jobs, we try to do it as if you're installing it on site. So you put your ductwork and your pipework in first, and we would let the containment be modelled around those elements, and you get the lighting in, and then we'd put the grills around those. So if there's a clash, there is a function, it's called clash detection. You click on that, you can choose what you want to compare, and then you get a list, hopefully a short list. And then once you click on that, you can say, take me to that particular problem. Some of them are insulation against insulation, and it's clashing by 2 millimetres because it's crossing like that. You wouldn't bother changing that. But other stuff, you've got pipe going straight to the middle of a steel, and you're like, how did I miss that? Whose fault it is, you've got to work together, really. Sometimes we move, sometimes electricians move.
Simon, have you taken any design consultants' models and then used that as a basis for an installation model?
Unfortunately, yes.
Yeah.
Yes. We have worked with one, I'm not mentioning any names, one particular job. We had the model, and the first thing I did is I did a clash detection, and it actually crashed my computer. There were that many clashes, so we decided, and I think that's actually a very good point, because if you get into that scenario, where do they stop and you start? Was what
exactly the effort they put in to produce the model, rightly or wrongly, you may then have to redraw and remodel, and then it's the effort twice.
Well, yes. Plus, well, what actually happened on that job? We started correcting it and putting it right, and then about a month later, we had a new model off them because someone had said we need another air handling unit for this area, and the 2 weeks we'd spent sorting out all the problems was down the toilet, basically, because the new model was their new model. Unless we grabbed all the new bits out of, but how do you know what's been altered? So the way to do it is there's a point in time where it's passed over to the contractor, and at that point in time, if there is a design change, it's marked up by the designer, and the contractor does it, because otherwise it's just going to be a mess. So there are, as I said, I know I whizzed through some of that quite quickly. It's all about sitting down and meeting and agreeing exactly what you're going to do, when and by who, because otherwise you can end up in a mess.
Simon, I've got a question. You said you're an installer as well as a designer.
Yes.
Are you thinking about moving into prefab units that you can get bolted together on sites? Is that, do you think, where you're going to go, or more traditional installation?
Well, we tend to do more traditional installation. It's horses for courses. I mean, some jobs just don't lend themselves to being prefabbed. We're doing stuff in one of the hospitals at the moment. It's all prefabbed because it's out of hours stuff. We're in there taking it out and banging in the new bits and pieces. We would only do prefab really where it would lend itself to the job, and then we would draw it up using Revit and make sure all the dimensions work before we got to site. But our experience is that it then gives complications of how do you get that item to site without damaging it, how do you get it into position without damaging it. So it's not always, sometimes it's been sold as being a benefit on jobs, and it doesn't always work out. I say it's very much our experience, horses for courses.